The last thing that we want to talk about here in this particular section is the idea that partial derivatives can continue to be applied even beyond the world of three dimensions. Notice here I have like a four-dimensional function because I have three input variables and one output variable. And it's entirely possible then for me to go ahead and attempt to compute like this triple partial derivative. All right, let's go ahead and actually try to do this. First, I would say I want the partial derivative with respect to x. So that means I'm going to treat x like the variable. I'm going to treat y and z like they are numbers. So in this case, I would get cosine of 3x plus yz. Then I'd have to chain rule. And the derivative of the inside here should just be 3, because again, y and z are just numbers. Now, if I wanted to do my partial derivative here, or take the derivative again, but with respect to x, I would just keep going. I would say, okay, well, this is going to be negative 3 times the sine of 3x plus yz. And again, I'd have to chain rule. Since I'm doing my partial derivative with respect to x, I should still get 3 back, because again, y and z are just numbers. The derivative of those is going to be 0. Ultimately, this is going to be negative 9 times the sine of 3x plus yz. Now, if I was to go ahead and calculate another partial derivative, this time with respect to y, going from here, I would say, well, this is going to be negative 9 times the cosine of 3x plus yz. And I'd have to chain rule to do the derivative of the inside. This time, though, notice that 3 times x is really just going to be a number. I'm treating x here like it's a number, so its derivative is going to be 0. When I do the derivative of y times z, now note y is my variable and z is a number. So the derivative there should just be z. In total, then, this kind of triple partial derivative is the same as negative 9 times z times the cosine of 3x plus yz. And I could have mixed and matched and done all sorts of different partials here. I could have done a partial with respect to z, with respect to x, with respect to y. I could have done all sorts of different partials in any order that I wanted and followed kind of the same general procedure that we had done throughout this entire section. On occasion, we will look at functions in this class that do have more than 2 input variables. We will look at functions that exist in 4 dimensions and try to understand a little bit about them. And so knowing how to take partial derivatives of those functions is very, very useful.